Go.
Hey guys, welcome to ClueCon Weekly. Today is May the, oh wow, I should know this already.
27th?
May the 27th. And this week we'll have Raymond with, who's the editor of the ORTC API. ORTC, for you guys that don't know, is a up-and-coming standard for video and all the stuff that we're using WebRTC. I'll let Robin cover that more here in just a few minutes. But also, just some quick news and announcements for you. Oh. And let's see here. So a lot of you guys have been looking for 1.4.19 FreeSWITCH. That is on the cusp. We should have that finished up today. So look for the tarballs packages, both RPMs and DEBs out there, and you'll know when that happens, as we will send out the release notes and the announcement on the mailing list and via all the good social media stuff. So if you're not following us on Twitter, Facebook, on the mailing list, be sure you join us in those mechanisms so you can get those updates. Also coming up this August is ClueCon. Mr. West, you want to tell us a little bit about what we've got going on there?
Well, ClueCon this year, we have 3 roundtables going on. August 4th, which is Tuesday, we'll have an ORTC roundtable. August 5th, we'll have a security roundtable. And August 6th, we'll have the FreeSWITCH platform roundtable. So be sure to stay tuned to our Twitter and Facebook feeds for more information. We'll post those on the schedule before the end of this week. And if anybody still has a talk they want to submit, please get that in as soon as possible. We're coming up on some deadlines, and I want to be sure we get the best of the best in. If you have any ideas or need assistance in coming up with ideas for additional topics, do not hesitate to reach out to us at marketing@cluecon.com, and we'll assist you. Well, you can bounce ideas off of us, and we can help give you some direction if you need some assistance. And be sure to register before June 1st. June 1st is the next date that the number of drink tickets you get, because we're giving a MacBook Pro away that's going to be laser engraved as the grand prize at ClueCon. And you must be present to win. So the sooner you register, the more chances you have to win. So let's get that in as soon as possible. It also helps me calculate my room requirements and lunch requirements and make sure, I'm not sitting here biting my nails all the way up until the day before. So that's pretty much it, Ken.
All right, guys. Thank you very much, Brian. So don't forget, follow us on Twitter for ClueCon, @ClueCon, and you can get all those updates from there as they're available. Miss Kathleen, how are you doing today?
I'm doing pretty well. How are you?
Oh, I'm doing all right. So you got a little info on the week in review for us?
I do. We had a handful of commits go in this week. Some builders fixed, an audio gap with native audio recording bug fixed, and a few other miscellaneous little fixes this week. And that's about it for the week in review.
All right, cool. So as one of those fixes I want to remind everybody about was recently we cleaned up files.freeswitch.org. If you were having trouble with curl, watch for the latest on that. You can grab that from Master, or it will be in the 1.4.19 release for you guys that were having a little issue with the 301 redirects. So there's a patch in there for that now, so just watch out for that. So thank you, Kathleen. Thank you, Brian. And Robin, how are you doing this week?
Doing well, and yourself?
Oh, I'm doing all right. Thanks for joining us. Do you want to go ahead and introduce yourself to everybody and then take it away?
Sure, I'd be happy to. So, Robin Raymond, for those who don't know me, I am the editor for the ORTC specification. I'm the former chair for the ORTC community group, but I've handed off my duties to Eric Lagerway on that just because of timing. And I work for Hookflash, but I'm not here on behalf of Hookflash today. I'm kind of putting on my ORTC hat today. So I'll just start into things. For those who want to have a portal to what ORTC is all about, please visit ortc.org. I'm going to have that link throughout the presentation. And today's presentation is going to be a mixture of high level and low level. So if you are interested in some of the low level, you'll tune in, and if you're not, you'll tune out. So Forgive me if I'm going a little bit too deep. So from a high level, what is ORTC? It's simply Object RTC. So ORTC in a nutshell is a do-as-I-say object control APIs for WebRTC. And for those who don't know, WebRTC, which everybody I believe on this call does, is basically a technology that adds real-time communication capabilities to web browsers without the need to install browser plugins, except for screen share, as we noted today at the moment. So ORTC is a community group. It was founded in July of 2013 by interested parties who wanted to define an object-based API for WebRTC. Currently, we have about 100 community group members. It was originally founded by Hookflash, and the authors on the ORTC specification include Google and Microsoft. The first draft, which is far removed from our current draft, was done in October 2013. And we have regular community group meetings about 1 to every 2 months. Summer kind of gets a little bit lighter because everybody's on vacation. But otherwise, we have pretty much regular meetings where we try to come to consensus within the group as to how we should be doing things. And most of the stuff is discussed on the list. And we have detailed bug reports as to what's going on within the specification and where we're at. So everything is very, very public. Just a mention about the ORTC API implementation status. We called for implementation, I believe it was October 2014. Internet Explorer has already said they're under development for their ORTC API. We also have an open source C++ version of the ORTC API called ORTC lib. It's primarily focused around mobility, and it's scheduled to be delivered late 2015. And all the links to that open source library can be found on ortc.org. It's an unstable early state at this moment, but has had a lot of development done. I just want to do a bit of a contrast between the difference between the ORTC community group and the WebRTC working group. Community groups are basically self-organized W3C groups who are interested parties who have come together to basically define experimental technologies for the web, whereas working groups are chartered by the W3C to define various web technologies to be implemented by the browser when they're ready. So a little bit of contrast, one's more experimental, one is more scheduled for implementation for browsers. And the idea here is that community groups can eventually, when they're ready enough, can bring their work into the working groups for finalization. So one of the things that we decided early on within the ORTC community group is we didn't want to disrupt the WebRTC work that was ongoing because it's very hard to define all the stuff that they're doing. And so we decided to define all of the ORTC API in this community group with the hopes that one day we'll be able to merge all these technologies together. So I'm going to do a brief run through for WebRTC, and it's going to be a running pace. So I'm calling it a run through. And in a nutshell, again, WebRTC is a simple browser API that allows two browsers to establish peer-to-peer RTC media connections. It heavily relies upon SDP to do what it does. And SDP, I think everybody on this call would probably know what that is. It's a compact and arguably very cryptic text format that describes an endpoint's media capabilities, networking, encoding, and encryption parameters. And WebRTC basically mutually exchanges these STP blobs where one browser describes what it's capable of and the other browser describes what it's capable of, and sends these STP descriptions over the wire, which starts it all together. So the question becomes, what's wrong with doing this? And there's actually nothing really wrong with it. It works quite well. It's very simple. You don't have to know a lot in order to get in a WebRTC session going. But anybody who works under the code knows exactly how painful that can be sometimes. But as far as a JavaScript programmer goes, they just create this SDP blob, shove it over to the other browser does the same thing, shoves it back, and we're done. And there you go, is a media and audio session ready to go. So it's quite simple. So from that standpoint, it's quite easy. But then the question becomes, well, why do we need ORTC if we've got this great thing? And the answer is simple. It's because not every scenario is a one-to-one audio video call. And if in crazy scenario like I've got here where you got full mesh going on between the various endpoints, you're basically going to have to do the negotiations between every single endpoint n times over, 1 to n times over. So it gets really complex really fast. And the other reason is because not every scenario is symmetrical in the sense that one side has an audio video channel, the other side has an audio video channel. There's a lot of times where you can have multiple videos being transmitted one way. And an example of that would be like security cams. You don't transmit your video to the other party, they're just transmitting to you. So that's an asymmetric scenario for media. There's more reasons beyond that. And if you're a programmer and you want to do some lower level stuff and adjust some details of how the SDP, the media engine actually works, well, you're going to have to write an SDP parser and generator to basically extract out all the information, reformat the SDP according, shove it back into the browser, and hope that the browser supports how you're trying to reconfigure it. Otherwise, you're kind of hooped. Is no API surface. Your API surface is adjusting this weird format and hope for the best. And it's not really a good way programmatically if you need to do anything detailed on how to control things that are going on inside of the media engine. So if you want to do things like adjust codec settings, fix your compatibility issues between the various, that's because no two browsers are necessarily going to have exactly the same SDP. And especially when you're throwing this SDP into external things that aren't even browsers or things that aren't browsers generate this SDPs, you're going to have all sorts of compatibility issues. And if you want to adjust the audio and video settings, well, good luck. So, and then there's just the pragmatic perspective when it comes to SDP. Some things are extremely difficult to define in SDP format. It's not that you can't. It's just that it's like trying to describe how you want to do all these complex things in a text format that was designed from the early 2000s and before that. So if you want to do things like simulcast or scalable video codecs, forking media scenarios, asymmetric audio and video, a whole bunch of different video capabilities and settings, and doing some weird mobility stuff that you're trying to do, describing all that kind of capabilities in SDP from a pragmatic perspective and defining standards around this is beyond challenging. And the WebRTC working group has taken great efforts, and my hat's off to them to be able to do this. But I can understand why this would be a daunting task, to say the least. So again, my hat's off to them. And ORTC is specifically designed to be friendly with a WebRTC. It is designed to have on-the-wire compatibility. So if you have a browser that does, or a library that only does ORTC, and you've got a WebRTC engine, on the wire, they should be able to talk, and the packets should be able to free flow. They support the same IETF standards when it comes to how packets go over the wire. So that should all work. And it's the ORTC API itself is designed to be rich enough that you can create a shim around the WebRTC 1.0 API. So a programmer could continue to program with the simple WebRTC SDP style API, but run that over an ORTC API engine and just use the polyfill to make it all work magically. So with ORTC, it's kind of giving you the best of both worlds. If you like the simplicity of the STP exchange and you just want to do that, no problem. You can just use the shim and away you go. So is ORTC, and it's not necessarily for everyone. And despite, I'm a big advocate for ORTC, I'm not going to promote it where it doesn't make sense. So anyone who needs a lot of detailed control over how the RTC media engine or the pipeline works for RTC will probably want to use ORTC API. If you want to do some advanced or asymmetric audio video scenarios, you're probably going to use ORTC. Mobile was definitely on the forefront of the ORTC mindset when we started this path, which is much more prevalent than it was when WebRTC first started out. And WebRTC, which is much more focused on the web browser, ORTC has been much more focused on mobile. So there's obviously a few, scenarios we really tried to think through what would be best for mobile. However, it is definitely more complicated than WebRTC 1.0. And it's not for the faint of heart. But we expect that a lot of media industry experts are going to take the ORTC API and create some wrappers around it, so the people programming at the JavaScript layer won't necessarily have that industry-specific stuff, but can still use an ORTC engine behind the scenes. So it's there when you need it, and hopefully you'll just shim it away when you don't. There's been a lot of issue because when the ORTC community group first joined, I came out with a post that, basically slamming, why are we still doing SDP? This isn't the right way to do it. We should be doing it in an object way. So the idea has been, and that's my fault, that ORTC is very anti-SDP. And I want to make that record clear. I'm not against SDP. I got no problem with it. It works well for what it does. But there are limitations, and that's what I was trying to indicate for the future, that basing everything around that is not necessarily the right idea. So it's good to have the best of both worlds. You want to be able to support SDP. You want to be able to support what SDP does. There's a lot of stuff out there, certainly, that uses it. It's going to be used well into the future. It works well for a variety of scenarios. I don't want to say that we should be doing it. It's just that there are a lot of other scenarios where that doesn't necessarily make sense. So you need to kind of have both. And this is what it's all about. And that's why ORTC was specifically designed to be shimmable, so that you can support both worlds. And just to illustrate here the concept, you can have a WebRTC 1.0 application. And this was a design goal from the beginning, that a WebRTC 1.0 application with just including a shim should work as is over top of an ORTC API versus just running natively on a WebRTC 1.0 API. And if we have succeeded in being able to do that, which it's designed to do, and this is something that our goal from the beginning has been, then we succeeded. If we fail on this, well, unfortunately, then we didn't succeed. Part of the problem in doing the shim, though, to be frank, is that the WebRTC 1.0 is a moving target. It's not stable. And so our goal is to kind of make the AppRTC sample apps work out of the box. And then basically people can tweak it for various scenarios from there and contribute back and keep all this kind of shim open source. To give you a contrast between the two APIs, if you want to, just think of it on this level, WebRTC is WebRTC 1.0 is very simple. You got a simple switch, basically exchange, and it just works. Whereas ORTC, you got a lot of knobs and controls and dials and switches and feedbacks, and it's very, very complicated. It's not to say that both don't do the same thing behind the scenes. It's just that one allows you a lot of detailed control, and the other you have to mangle and munge STP to do the same kind of work. So that's kind of the difference. And WebRTC is evolving. The idea here is that we're contributing both directions. where we're trying to, contribute to the WebRTC 1.0 group, and we're trying to follow what the WebRTC 1.0 API is doing, and where the objects and properties and attributes are the same. We like to adopt what they're doing, and hopefully they'll look at what we're doing and be able to adopt the same kind of object models. So they kind of, it's an evolutionary strategy where we're not just going to have suddenly we wake up and we have an ORTC API and the world is different. It's more a long-term process here. Obviously, IE is kind of going straight to ORTC, but again, that's where we can have the shimmable approach, where the shim can follow the standard as it migrates towards the ORTC model. And then when you look at what ORTC can give you, you get this incredible amount of objects that exist. And I ask this somewhat facetiously, what programmer doesn't want control over all? I mean, you get all this wonderful stuff that you can do, and it's all wonderful and great. And I say that because there's a lot of complexity here, and I don't want to pretend otherwise. I'm going to go through, and this is where I'm going to go a little bit deeper here. And for those who don't care about the objects that exist in ORTC, you can just tune off your brain for a little bit. And hopefully for those who are a little bit more interested, you'll get a better understanding for what's underneath the hood and what objects you're going to have to play with. So there's head there. These are the main objects that exist. You see that 3 of the main objects are all ICE related, and incidentally, a lot of our bugs are all ICE related because of that in the specification. You've got a DTLS there, you got RTP senders and receivers, and so you got and then you got RTP listener, and then you got the little data channel sitting there on the side. Those are actually the names as they exist within the specification, except they're all prefixed with RTC in front. So gatherer, this is one of the objects that exists. This is kind of the root fundamental object, which you kind of start with for getting things going. The idea here is that this object will gather all your host, reflexive, and relay ICE candidates. Therefore, it will open up local socket ports. It will go and open up your turn relays. It will gather up all those candidates for you and get them ready. It will also gather for both UDP and TCP. It has a local ICE username fragment password. It listens on the wire for ICE packets, SRTP packets, and DTLS packets that are coming in. It routes the ICE packets to the RTC ICE transport objects as they come in, and demuxes them based upon the remote username fragments. And it also routes SRTP and DTLS packets that are coming in based upon the 5-tuple IP pairings. So it basically, as packets come in, to the correct ICE transport that is attached. But I'll go a little bit more detail there. And again, forgive me if I'm jumping too fast. And then there's called an RTC ICE transport. And the idea here is that you associate an RTC ICE transport to a gatherer. And this thing actually sends out the ICE connectivity checks. So this is the object which will send packets to the other part of the globe, which ports actually work, whether it be host, relay, or reflexive ports from the firewall, and actually responds to the incoming ICE connectivity checks from and it forms a virtual circuit for which DTLS packets and RTP packets, media packets can flow. So the ICE gatherer basically opens up your ports, and transport objects creates your virtual circuit, which media packets can pass, can go back and forth. And I'll show you a little diagram of what I'm talking about here. So if you wanted to look at the objects from a local and remote perspective, you've got a local gatherer at the bottom, and you got a nice transport on top. Both sides have to have a nice gatherer the remote party and the local party, because it has to open up ports and test out your firewall and open up your relay. And then you need an RTC ICE transport on top to actually test those paths between the local and remote. So the ICE transport is the pairing between the local side and the remote side. No idea about a remote at all. All it does is open up the ports. That's it. It's the ICE transport that actually tests between you. Okay. And this is where it can get really complicated. You can have a single ICE gatherer, and you can have multiple RTC ICE transports where you have a local party and a bunch of remote parties. So let me give you a scenario. You've got Alice, and Alice is calling Bob, and Bob has 5 devices which he's listening on. You know, a mobile device, a server, you know, some kind of desktop, and wants to open up a port to all of them. Well, you can do that. You can create a local gatherer. You can create a transport per destination that you're going to, and each transport tests each remote destination locally, and you have one transport per destination that's out there. And obviously, you can create new transports on the fly, and you can destroy them. You don't need them anymore. And so if you wanted to have a scenario where only one party answers, you can create all of them, negotiate with all of them, and the one that answers, you can destroy all the rest. Or if you wanted to maintain where it's actually, you know, forking literally to every single destination that you're calling out to, you can also do that, where you maintain all of your ICE transports alive, and then you maintain a virtual circuit between every local destination to every remote destination. Well, there's only one local destination to every local source to every remote destination. So it can get quite complicated, but for the local one-to-one scenario, it's pretty straightforward, simple. You got one-to-one, and then you got one-to-end. Okay, then we're going to throw in another object into this whole mix here, DTLS transport. So the DTLS transport is responsible for SRTP, negotiating the SRTP keys. It encrypts and decrypts the data channel packets. You can only associate one DTLS transport to an RTC ICE transport. So you have, for every ICE transport, you must have a DTLS transport for the sake of encryption. It's separated because it has separate information and separate state related to everything to do with SRTP and DTLS. And it sends and receives packets over the virtual circuit which the ICE transport sets up. So the ICE transport sets up your local and remote transport, and the DTLS takes advantage of that and sends all its packets through that virtual circuit that happens underneath. And the DTLS transport does require a fingerprint validation to consider of the DTLS certificates in order to consider the path secure. Because otherwise you open yourself up to a man-in-the-middle attack if you don't verify your DTLS certificates that you're negotiating on the wire. That's like having TLS without a trusted root. In this case, you don't have a trusted root. You instead just verify the fingerprints, and if both parties see the same fingerprints, then you're golden. Or the fingerprint of the remote party, I should say. Then you're golden. So I'm going to add it to the previous diagram, this object. So before we had at the bottom we had the ICE gatherer, and then top of that you had your ICE transport. Now we have a DTLS transport on top. So the DTLS transport encrypts, sends it over the ICE transport. The ICE transport uses the ICE gatherer's ports to send to the remote party, and then on the other side it receives it and through the ICE transport. And then it sends it through the DTLS transport for decryption. And this is always bidirectional, by the way. All media paths are always bidirectional. All paths here are always bidirectional. Now I'm going to complicate by throwing in another object here, if we don't have enough. So you can have what are called RTP senders and RTP receivers. And senders, you can have many RTP senders and receivers associated to a single DTLS transport. So your DTLS transport is your encryptor, and your senders and receivers are basically taking media tracks on the one end and encoding them through the DTL, and then encrypting it through the DTLS transport. And on the other end, the DTLS transport has them demuxed into the appropriate receivers so that the receiver can emit a media stream track for rendering on the remote side. So one side does the capturing and encoding, and the other side does the decoding, and then you can render where you need to on the remote party. Media currently supports one of either audio or video. Presumably that could be something else in the future. The data channel, I mean, there is data, but it's not really, you don't use the RTP senders and receiver for data channel. There's a separate API for that, because there is a separate API already in with objects already in the WebRTC 1.0. So we're just reusing that same kind of model there. And the senders and receivers take a whole bunch of parameters, which you can define all the codecs, all the detailed SSRCs you want, how you want to do scalable video coding and layering, how you want to set up simulcast, everything you can ever want to do encoding-wise, you can define on the RTP sender and receiver, and away you go. You can also get the capabilities of the sender and receiver, because the sender and receiver might have different codecs capabilities, and a bunch of other capabilities that are all defined in the sender receiver. So these objects have a lot of detailed parameters in which you can define anything you want to go over the wire. It's also a great big shotgun to point at your own foot and get it wrong. So you have to be careful. This is not for the faint of heart. So to add it to our previous diagram, which we're building up here, again, at the bottom, you have your gather, which is all about your ports. You have the transport, which creates your virtual ICE transport, which creates your virtual path between you and the remote party. You have your DTLS, which negotiates your SRTP keys and does all your encryption. And then you have a whole bunch of senders on the one hand and receivers on the other. So the senders take, each one has the media input, and on the receiver, each one emits a media stream track on the output. And this scenario is asymmetric in the sense that one side is sending and the other side is receiving, but presumably you could have both senders and receivers on the one side and senders and receivers on the other when you want to have bidirectional media. But this is just showing a very simple scenario, and to keep the diagram not so complicated, I'm just doing this like this for the sake of brevity. Okay. Now, because it's not complicated enough, we have to throw another object on the whole mix here. What's the RTP listener? And the RTP listener is only on the receiving end. So when you receive media packets over the wire, there needs to be something that takes those media packets, demuxes it to the appropriate RTP receiver. So we call that the RTP listener. Now, you don't actually have to have one of these objects for it to do that. There's always one underneath the hood, whether you're asking for it or not, because there's always something that needs to do that demuxing logic. So it always exists. However, if you want to receive events where you don't necessarily know all the packets that are going to come in advance, and you want to be able to set up RTP receivers on the fly, well, this object you can receive events from where it will tell you, hey, I got this RTP packet that is coming in, don't know what to do with it, just tell me what to do. So then you can set up an RTP receiver, wire it to the DTLS transport, and suddenly that can all magically start demuxing because you set it up. So this allows you to create RTP receivers on the fly without having to pre-create them. So to add it to our previous diagram, it's the same diagram, let me just show you, as 2 up, except now we've got this RTP listener between the DTLS transport and the RTP receiver, and that thing does the demuxing. Again, it can be hidden, or it can be explicit in the sense that you can create this object and then listen for events when you want to know about RTP packets that you didn't already create receivers for. And then finally, the next major object we have is called the ICE Transport Controller. And the ICE Transport Controller's job is to coordinate the freezing across, ice freezing specifically across ice transports. If you don't know what ice freezing is, you probably don't care much about this guy. But if you do know, you will care. And the idea here is that if you're sending RTP and ice over multiple ports, for example, you're sending audio over separate local socket ports, you're going to want to reuse your ice knowledge. So you don't send packets all over the wire. Instead, you want to do is you want to test like your audio path, and once you got your audio path set up, you're going to want to just use the information that you discovered, which paths work well for the audio, and reuse that knowledge for video, so you can really optimize the scenario for ice testing for video. I don't think that everybody's going to care about this. I also think a lot of people are just going to mux audio and video over the same port, so this probably won't even come into matter for those people. But if you care, or if you need ability with SDP, because there is a requirement for audio and video to be unmuxed for a lot of scenarios, to do this for those scenarios. And this is a little bit of a separate diagram, because you can kind of think of the transport controller of this object that kind of sits to the side. And it just regulates the ice transports. No packets actually flow through it. It doesn't actually do anything with any packet anywhere. All it does is dictate the order in which ice is unfrozen between different transports. Oh, and I also forgot to mention that it handles bandwidth information. So if you got audio and video on separate ports and you want to say, hey, these two are actually kind of related, I want to negotiate, I want to keep track of my bandwidth between them, well, you can set up an ICE transport controller to do bandwidth estimation across the audio and video, so you can kind of see it as a package as opposed to two independent objects that are just sitting out there. So that's kind of what the transport controller does. So when you throw it all together, you end up with this kind of diagram, where you got a pipeline where on the one end you have a media stream track that starts the whole thing, goes to an RTP sender, which encodes the media data into the appropriate codec format, sends it over the DTLS transport for encryption, sends it over the ICE transport virtual circuit, which sends it over the physical port of the ICE gatherer, which then sends it over the internet to the remote party, which sends it, via the ICE gatherer to the ICE transport, which then sends it for decryption on the DTLS transport, demuxes it through the RTP listener, which sends it to the appropriate receiver, and then out comes a media stream track on the other side. So ORTC is all about controlling the plumbing and the details of how the media stream pipeline works in the RTC engine. And for a very quick sample, I literally created this slide last second here. I should have had a better illustration of examples, but we have the ORTC spec, which you can look at. I'm sure we'll have more details later. The idea here is you have your media stream track. You send that into you also create a gatherer, and based upon the gatherer, you associate an ICE transport, which you associate to a DTLS transport. And then you take your sender, which takes your track and your DTLS transport. You signal a bunch of stuff between you and the remote side, and you start your ICE transport, which creates your I got a little typo there. You start your ICE transport over your ICE gatherer, and then you set a whole bunch of parameters for encoding, and then you go sender.send on the one send, and then receiver.receive. I'll fix this slide for you guys, and it'll be a little bit better. Sorry about that. And that's it for the detailed walkthrough. So you kind of set up your pipeline, and away you go. That's it. I want to talk about the ORTC lib, which is an open source implementation of ORTC, which is underway. It is a C++ library, which heavily uses a lot of the media engine from the WebRTC engine within Google Chrome, but strips away and changes some of the objects that don't really fit well for the ORTC API. And I'm specifically talking about the ICE engine. ICE for ORTC is greatly enhanced versus the WebRTC that's there. And there's a change in the DTLS because of the pipelining and object dependencies more than it has to do with technically being wrong. There's actually nothing wrong with the WebRTC implementation in Google Chrome. The ORTC API, the ORTC lib is very mobile friendly. It's designed so you can do a simple git repo clone and basically type build on the command prompt, and it's all ready to go. Its targets include iOS, OS X, Android, and Windows. And you can build basically mobile and desktop applications with the ORTC lib. And then finally, because it's a C++ library, you can wrap it in other languages like JavaScript or C# and Objective-C, and then you can have higher level language around the C++ implementation. So, that anybody can take down and build applications with. That's about it for ORTC lib. And that's it for my presentation. I hope it was not too in-depth and or maybe not in-depth enough, I don't know. So I'd love to answer some questions about it at this point and go from there.
All right, anybody have questions for anybody have any questions at this point? Go ahead, hit 0 to unmute yourself. You can ask in the IRC channel, or you can ask in the if you're on the web interface. Nobody?
I'll do it. How's your debugging? Do you have debug logs?
Sorry?
Do you have really good debugging logs? Like explaining everything that's happening? So like if you're trying to do interop. I noticed one thing in Chrome right now, it's like mind-numbing trying to figure out what's going on when something doesn't work. Because there's either too much debug or not enough, or you can never quite put your finger on what to look for.
Yeah, it's a delicate balance. There is an incredible amount of logging that we've added to the ORTC lib just in development to find out what's going on, because it can break down in any object. So we have added a lot of logging capability, and at different log levels. The problem is it depends on what you're trying to debug. The log levels can completely be wrong. What I'd like to see is Microsoft has a really great concept around event tracing, and I'd like to move to more of that model. But that is a long-term project, because basically you have to define every single event that gets emitted out of the engine, and then create producers around every single event, which you group together. And then you can target the individual events, which you can do analysis on. And it's really, really powerful, but takes an extreme amount of effort versus just saying, here, output a log statement here, and away you go. Having said that, we do have a lot of capabilities in the engine where you can, for example, open up telnet ports. You can literally telnet into a socket that is available on the device remotely, listen to what's going on, and output all your log statements in a JSON format that you can actually parse down and take down. You can output to a pipe. You can output to a file. You can output. So there's a lot of capability there. but I'll never ever claim that we got it 100% right, and there's always a tremendous amount of room for improvement.
Great.
I've got a question. I've got one that's kind of along the lines of what Tony did, and this is something we run into while working with Chrome. The ability to rebuild this from source, is that something that's well documented? Is it voodoo, black magic that requires a lot of trial and error?
You're talking about from a scripting perspective, where you to go to clone and how the magic that you have to do from there?
Yeah, the process of taking nothing and building it.
Yeah. Well, one of my biggest complaints against the Chrome guys, and they've done a tremendous job given what they have to do the Chrome repo, is that you have to have installed all this incredible amount of tooling just to get it working, and then you do some magical environment variables, and you're not quite sure what to set. A lot of specs and how to do it. So the one thing that I've tried to do from our perspective is to set up simple repo, which you can clone recursively. It'll pull in every single repo that you need from every single source. And then there's one script which you run, and on Windows is like a batch file. And on Mac, you can just run a bash script. I haven't the Linux version yet, which I'd like to do for the sake of Android. But presumably there will be that as well. The script, everything. The one advantage to the Mac, you already got like your Perl and everything already installed in most people's machines. This tool now, so it'll actually output and say, "Hey, where's this tool?" And I think we just require Python and Perl to get it going, because we have to generate those projects for WebRTC, the WebRTC engine. But it should be magic after that point. You install it, you go, and that's it. You run the one script, it's done. It sets up everything for you. Presumably should handle every single environment. But of course, we're going to make mistakes, and it's not going to work everywhere. But that's the nature of open source too.
But you've made an effort, and that's.
We tried our. Unfortunately, I don't have enough beta testers out there to really say we got a single scenario.
Awesome.
Can we expect a solid future to see the signaling? I'm not sure what you're asking, Victor. Are you saying that can we expect WebRTC? No, it's more that I don't know which question you're asking. Are you saying that can we expect WebRTC to use ORTC for signaling? Or can we say that WebRTC signaling is going to be stable from here on in? Or maybe you're asking both. Well, yeah, okay. So RTC has no signaling. It's strictly a control API. So you got a bunch of knobs and dials, very advanced stuff for people who understand the guys do. And so all of those knobs are present. So it doesn't tell you how to signal anything. It's up to you to signal all your SSRCs, all your codecs. It does give you all the information you'll need to signal, but it doesn't tell you how to signal. It doesn't tell you anything. WebRTC doesn't have signaling from like a SIP perspective, but I would say it does have. You still need to do a full round trip between you and the remote party for SDP. You kind of bypass it by doing some generation of the SDP. You don't actually have. It doesn't actually have to come over the wire. In theory, you could just signal whatever you generate the SDP locally and then pass that into your browser, as opposed to actually coming from the remote party. But in concept, at least, you have to do a full handshake, whereas ORTC has no handshake. It does have a handshake in the ICE sense, but it doesn't have a handshake in the here's what how we're gonna communicate sense. So as far as stability goes, the whole hope is that WebRTC, anybody who has the SDP, can continue to do so from here until nobody cares about SDP anymore, and I don't expect ever going to change, and certainly not in the near term. And I can imagine 20 years from now, we'll still be doing STP. I can't see why it'll change instantly. So I expect it to be very stable. What I think will change, though, is that you're going to see a bunch of libraries around the ORTC implementation in the future, which take advantage of the objects, but have your own specific STP scenarios more targeted to what you're doing, maybe various fragmentation of the STP implementations, or maybe just a master big one that handles everything. I have no idea. But at least you can do that. Like, there's nothing saying that you can't build your own STP interpreters in your way, however you want. And the great thing and the beauty about it is you should be able to take that engine and put it on any browser you want, and it's completely stable by virtue of it being the same parser and generator on both browsers. I hope that answers the question.
Guys. All right. Does anybody else have any questions for Robin?
So is your API planning on using, is it like a JSON chunk of all the different capabilities?
Yeah, look, that's a very good question. So a lot of our objects are return capabilities and accept parameters. And the idea here is that capabilities are basically dictionaries. And with any one of those dictionaries that are returned, you should be able to just stringify it, put it as a JSON blob, send it over the wire, JSONify it on the other side, which gives you all your capabilities. As far as the setting goes, the same thing. The parameters are all dictionaries, so you can stringify those and JSONify them on the remote side, and away you go. So yes, the idea here is that it is easily convertible from dictionary to JSON format. The difference is that we don't have one master plan. Like STP is one big blob, which has everything. There is no master blob. You basically are going to have to stringify a bunch of different little blobs representing the different objects, which you can always put into a master big if you want, or any format that you want to.
So is an STP still the best way to send the whole thing as one hunk? If you're sending...
That's up to you, because you can use the objects however you want. You can do whatever you want. Now, STP, even the reality is, even with the WebRTC, STP doesn't send everything all at once. It sends everything that it knows when you first start, but then adds candidates later, which really are supposed to be part of the STP, but they come later. So in ORTC, it's the same kind of model. You can get all the information it's got right now, and then it'll fire events later saying, here's a bunch of new candidates, or here's a bunch of new information as we have it.
You can also wait until you get them all to do anything?
Yep. You absolutely can. And you receive an event telling you when it's basically it's gathered everything it's got.
But then you'll get something that's, when you serialize it's JSON, that's suitable to use the same way STP is used now, as far as like send it over signaling to somebody?
Yep, absolutely.
Like, is there any plans? Like, I assume Chrome is probably implement a STP generator on top of that and keep everything the same, right?
I don't know how Chrome is going to do it, whether they're going to maintain it as physical C++ code within the engine, whether they're going to do it as a shim. The idea is that you can do it either way. I don't know their implementation path, whether they're just going to implement API by API as existing objects in their code, or whether they're going to do the whole kit and caboodle. I have no idea what Chromium's going to do. I know that they're completely overwhelmed for what they're doing. They got a lot of work to do, and obviously they're much bigger in their number of endpoints they're trying to support at this point and scenarios. So I can imagine it's a complex job that they have to do.
So I guess to rephrase to make sure I get it, is there a way to produce a serialized JSON that contains enough to render that as an STP? Like everything that an STP would have said?
Yes, one of the things that we've gone through is we've gone through all of the RFCs around the SDP, and they change because it is a moving target, but we keep going through all the proposals as well as all of the existing RFCs and make sure that every piece of information that you'll need to SDP is available to you as both a capability side on one, as well as a setting on the other, so that you can tweak various knobs that are exposed to SDP, as well as other things that aren't, you know, as obvious in terms of, for example, ice freezing. Well, we needed to add an ice transport controller just to be able to get the freezing properties right, even though it's not really something that you JSONify, so to speak. That's more of an object setup scenario.
So maybe the serialized JSON could be used interchangeably how they use SDP now. Like you could send that whole JSON to the other side and just hand that to an API function if you want, if you don't need to dig deeper.
Yeah, if you don't need to dig deeper, that's absolutely true. But I still think that for someone who's just trying to do a simple one-on-one, SDP is way easier than this, because in this scenario, you got to set up a bunch of objects. Now, I know we're going to provide samples, so it's going to become effectively as easy, but the reality is it's certainly a lot more to set up than for WebRTC 1.0 API. But presumably you.
Sure. Well, plus it offers a place to add more stuff. So
yeah,
since we have our virtual area that we're in right now, I'm just thinking towards how we would use it.
Yeah, and that's one of the targets, is that when we were trying to do work with WebRTC from our stuff within Hookflash, it became really problematic to do a lot of the stuff that we're trying to do, because we're trying to do a lot of scenarios that really weren't covered within the SDP model. So, you know, it's a little bit out there. So for us, it became very problematic. But just from my own history, I don't know how many of you are familiar with XLite or XPro, the clients that I wrote way back in the day for CountPath. And, you know, I come from a background in the SIP SDP world, and I know how many flavors are being out there. And then you have to have these engines that just make compatibility between all the different SDPs, between all the different SIP variants, between all the different things that exist, and it can become quite problematic. And my biggest concern at the time was making this compatible in the future, especially when you're throwing in audio and video and advanced scenarios, and everybody getting it right across every single browser, across every single implementation, and making sure that they're all up to date is going to be extremely challenging to the nth degree. And so having the ability to SDP outside the browser and having an updatable library to the latest fixes and everything else that's out there, I see is very advantageous. So that was actually one of my strong motivations, is to make SDP more compatible when we started than anything else, as well as supporting the advanced scenarios that weren't, you know, out of the box with SDP.
All right, guys. Any other questions for Robin this afternoon?
I'll say something for ClueCon.
Yep. You're coming to ClueCon, right, Robin?
Yeah, yes, I am. I got to get my plane ticket in order here, but yes, I am.
Yeah. So for you guys that have been listening, Robin will be part of the ORTC panel there at ClueCon there on Tuesday. So ORTC, I think, is something exciting that we're all going to be watching. So you definitely want to come in and see where they are. I'm on the ORTC mail list for the working group, so I see the emails going across there on a regular basis. So these guys are working hot and heavy, and it is on the standards track. So you guys keep an eye out, and if help out where you can. So Robin will pop by on occasion, I'm sure, to give us some updates in the future, and you can always see him at ClueCon. So definitely show up for ClueCon, and definitely thank Robin for showing up and giving his presentation today. I personally want to extend my thanks, Robin. It's been very informative, both at a high level and a low level, so I want to thank you for coming in.
You're welcome, and I invite you all to join the community group. There's hopefully no war between the WebRTC group and the ORTC group. It's a lot of the same people actually wearing different hats between the two groups. So there's a lot of crossover going on, but the idea here is to keep the work between what we need now versus what's coming down the pipe for the future, and some really good input for the WebRTC guys, based upon implementation feedback. Once we implement and discover, hey, this doesn't work very well, we need to do this, we can hopefully get that feedback well in advance for the WebRTC people when they come to take it down, or whatever they decide to do.
Cool. All right, guys. All right, so once around the horn, thanks for coming out, Robin. We really appreciate it. So, Mr. West, Mr. Jarris, either of you guys have anything to add before we wrap it up today?
No, sir.
All right. So if you guys want more information on ORTC, I believe that's ortc.org. Is that correct, Robin?
That is correct.
Right. So you guys can visit. So I know there's a lot of good information. Visit there to find out and with the ORTC and keep up with the latest changes and find out who else is working on that. So also don't coming up in the very near future. So if you have not registered for ClueCon yet, visit us at ClueCon.com. Get your registration in there. We do have some open slots for speakers, so we're going to be picking the best of those. So get your proposal in now. Visit ClueCon.com/call for speakers, and you can get your speaking proposal submitted there. All the information you need is there. If you have any questions about ClueCon, email me, krice@freeswitch.org, or email Brian at freeswitch.org. Or you can always visit ClueCon, get the phone number, and call Brian. I'm sure he'll be happy to take your questions and help you out any way you can. So thanks, guys. We'll see you next week. And don't forget, follow us at Twitter, on Twitter, at FreeSWITCH and at ClueCon for all the latest updates. Thanks, guys. And Brian, we'll wrap it up.